responsible.
Chandra,
D, sir.
tell me. B,
D.
D. Okay, let's check. Aditya?
C, sir.
Okay, right. Abhishek?
Sir, A.
Abhishek is saying A. Ratna?
Sir, D, sir.
D. Okay. Chalo, let us check. It's a very simple question actually. It's not difficult at all. So if you see the movement of the block, there is only one force acting on the block. Yes, Likhita?
Sir, I also think it's D.
Okay, let's see. So the block motion, there is only one force, that is a spring force, that is equal to minus kx. So if it is minus kx, then acceleration is equal to minus of k by m into x. Okay, no? So it's a retardation basically. So a is proportional to x, magnitude of a is proportional to x. So it has to be a straight line. So if it is a straight line, C is the only option which is correct. Okay, now fine. Is that clear to everyone? Okay. Chalo, let us solve this one now. This one will take a little bit time. So try to analyze this one. Abhishek,
Sir, C.
ऐसे randomly मत बोल, सोचो सोचो.
Sir, C.
Okay, fine. Wrong answer. Banu, any answer?
Sorry, sir, by mistake, sir.
No. Did you do this question? Aditya?
Sir, I think again C, sir.
C?
C.
Okay, let's check. Chandra?
Sir, A.
Okay. Ratna?
Sir, A.
थोड़ा सोचो ना यार, everyone. Don't tell the answer randomly. Think on it again and again. See what I will do. I will try to visualize this with the subsequent motion of the system. Like, let's say that B is coming down. So when B is coming down, actually, C is moving rightward. A will continue to be at rest on the ground. So at this point, acceleration of B plus C will be mb into g divided by mb plus mc. So velocity will be equal to a into t, as initial velocity is 0. So we'll write mb into g divided by mb plus mc, that into t. This is v. Okay, no? So as you can see, as a t increases, v also increases. Correct? There is no problem. But the instant B hits the ground, there will be a jerk felt on the string. So initially, see, velocity is increasing with time. It is there on this graph as well as on this graph, because ये दोनों तो cancel हो गया पहले. Because they are showing the non-linear nature. यहाँ पे constant show कर रहा है, तो constant is not possible. Sinusoidal curve is also not possible. So these two are out of the equation. So there are only two possibilities, this one and this one. Now next, when we are talking about the jerk means what? A sudden large force is applied over a short span of time. So in V versus time graph also there should be a jerk. So option D is the correct answer. If you analyze the subsequent motion after that, what you will see that actually when the jerk is felt, C will continue to move in the right hand side and ये spring extend होता जाएगा, तो ये retardation हो जाएगा ना. So retardation at this point of time it comes to rest. Then again the spring force will pull it up. So this motion will be repeated. But you don't have to consider the remaining portion of the motion, because the moment you can see the jerk, so you can clearly tell D is going to be the answer. Okay, understood? Yeah. Chalo. So let's proceed. Now next, there is a very good question, and I'm again telling you, you take time. There is no hurry. Don't tell me the answer in a hurry. Take time and solve it completely, then tell me the answer. Okay, no? Yeah. This question is a multi-correct question, huh? So be careful. It's a multi-correct question. Yes.
Sir,
Yogita.
A and B.
Okay, Hardik.
Sir, A and C.
Okay, Abhishek.
Sir, A and B.
Abhishek. Okay, Puneet. Aditya.
सर ए एंड सी
ये भी होगा सर.
Okay, चेक करेंगे. सुजल.
सर ए बी.
Okay, Abhinav. Abhinav.
सर ए बी.
Okay, चलो. हर्षित.
Sir, AB.
Okay, Chandra.
ए बी सर.
Okay, sir. Altaf.
सर ए बी
Fine. So now that is why I am telling continuously कि take time and then answer. You know. See, let us check. So F is equal to alpha t. Sai.
Sir, ABC.
Very good, Sai. Excellent. Very good. Very good. So F equal to alpha t. Yes, Sai. Right. Okay. So now A is equal to alpha by m into t. So dv dt is equal to alpha by m into t. So from here we can write v is equal to alpha t square by 2m. So we are getting v proportional to t square, a is proportional to t. So from these two equations I am getting v is proportional to a square also. So A, B, C correct. Ratna?
नथिंग सर.
Okay. Right. Aditya?
सर सी कैसे होगा सर?
कौन सा? C?
सी कैसे हो सकता है?
ये देखना v proportional to a square आ गया ना. तो वेलोसिटी और एक्सेलरेशन का जो ग्राफ है वो भी तो पैराबोलिक होगा.
एक मिनट सर, देखिए सर, फर्स्ट वाले में हाँ
First-
ओके ओके समझ गया सर.
फर्स्ट वन स्ट्रेट लाइन है तो वो तो करेक्ट हो गया. सेकेंड वन भी पैराबोलिक आ रहा है वो भी करेक्ट हो गया. थर्ड वन v और a का नेचर भी पैराबोलिक है तो वो भी करेक्ट. राइट ओके ना. हाँ चंद्रा सर,
इसमें का क्वेश्चन क्या होगा सर?
तू पहले एक क्वेश्चन को ठीक ठाक से आंसर कर, उसके बाद देखता हूँ.
ठीक है सर.
ओके चलो, सो लेट अस प्रोसीड. प्रोफेसर,
Sir, alpha is proportional to A square कैसा आया sir?
अल्फा कहाँ से मैंने लिखा प्रोपोर्शनल टू ए स्क्वायर में?
सर एक सेकंड पीछे वाले पेज में जाइए.
भांग खा के आया हुआ है
सर
शायद भी. भी
सर
प्रोपोर्शनल टू
वेलोसिटी
ए.
से. सर एक बार
हाँ.
बताइए ना.
तो a इज इक्वल टू मान ले के टी है और v इज इक्वल टू मान ले c इंटू टी स्क्वायर है. दोनों को डिवाइड कर. तो तेरे को नहीं लग रहा है क्या सम कांस्टेंट c बाई के इंटू रूट के इंटू टी होल स्क्वायर?
यस सर.
आया समझ में?
हाँ ओके सर. थैंक यू सर.
मोस्ट वेलकम. Now next one is again a question which will require some time to solve. So I request all of you take time, solve it perfectly, then tell me the answer. Okay, do not tell me the answer in hurry. Chalo everyone, do it. आदित्य,
सर इसके दो आंसर्स होंगे ना?
हाँ ये मल्टी है,
हाँ ठीक है।
मल्टी करेक्ट। Anyone with the answer? अच्छा, take time, no issue, no issue, no issue. Yes, Bhanu.
Sir, A and C.
Bhanu, A and C. Perfect answer. Very good. Excellent.
Thank
Very
you,
good.
sir.
Very good. Aditya,
हाँ सर, ए और सी है।
हाँ correct. ठीक है. Okay. चलो, let us explain. First, you think about this point B. देखो, everyone, don't raise your hand now. Match your analysis. A and B. It's like this. Okay. So this angle is beta. Okay, no? So at this point B, tension is in this direction. हाँ Sai, okay, very good. Very good, Sai. Okay. So now this tension will have two components. One is this one. This is tension T2. So this is T2 sine beta. This is T2 cos beta. This is mg. This is also mg. So T2 sine beta is equal to mg. T2 cos beta is equal to mg. है ना? So if you do, tan beta is coming to be 1, so beta is equal to 45 degree. ठीक है, this is one part of the story. So now let us come to point A. Point A check करो. For point A, this is tension. Altaf, after some time, please. So this is T1. This is T2. So this one will be T1 sine alpha, and this will be T1 cos alpha. In this direction, this is T2 cos beta. So I can write T1 cos alpha is equal to mg plus T2 cos beta. Acha, T2 cos beta was already equal to mg. So this becomes 2mg. Okay, no? And T1 sin alpha is equal to T2 sin beta, that was already equal to mg. So if you divide these two equations, what you are going to get actually, tan alpha is equal to half is equal to tan beta by 2. So tan beta is equal to 2 tan alpha. That's done. A is done. Next, you come for this equation. You come to this equation. What I have written, T1 sin alpha is equal to T2 sin beta. Value put karo. T1 sin alpha means, acha, tan alpha equal to half. So sin alpha is 1 by root 5 is equal to T2 sin beta in the sense 1 by root 2. So C is also coming to be correct. Okay. So A and C is the correct answer. Snehita,
So once you show this question.
which one? Previous page?
Yes, sir. This question.
Okay.
Yeah, thank you, sir.
Okay. Yeah, Altaf?
Sir, can you please increase your voice?
Increase my voice, huh? This is okay.
No, sir, और थोड़ा बढ़ाओ.
और थोड़ा चिल्लाना पड़ेगा इसके बाद.
हाँ, बस.
आजू बाजू में लोग भाग जाएंगे फिर.
ठीक है सर.
चंद्रा?
इतना ठीक है सर, उतना
ठीक है.
चिल्लाना मत.
अच्छा ठीक है भाई.
इतना ठीक है.
चलो, let us go for the next question. हरतना?
सर कल छुट्टी है सर.
किस खुशी में भाई?
सर कल मिलादुन नबी है सर.
पता नहीं रे, ये लोग छुट्टी इस बार दशहरा में दे दिए, मतलब बहुत ज्यादा मिल गया. हो सकता है, मे बी. आई एम नॉट अवेयर अबाउट दिस. ठीक है ना. पुष्कर तो खाली यही सोचा है कि कैंपस कब आ जाए बस. पॉसिबिलिटी बन रहा है भाई. It is going in positive direction only. COVID cases in Telangana is decreasing drastically. हार्दिक?
सर पहले 1 लाख केसेस आ रहे थे, अब 40,000 केसेस आ रहे ऑल ओवर इंडिया में.
हाँ, तेलंगाना में तो और भी कम है ना. 500 आए थे
नहीं,
बस कल.
ऑल ओवर इंडिया में पहले 1 लाख केसेस आ रहे थे सर, अब 40,000 आ रहे हैं.
हाँ, तो इसका मतलब है कि टेस्टिंग कम करवा रहा है ये लोग. ये लोग वहाँ आरामी किस्म का लोग है भाई. कैसे भी ये लोग कम करके दिखा देंगे उसको.
सर तो और रहेगा ही, पर दिखा रहे नहीं है.
हाँ, प्रीतम?
सर A and C.
Okay, we'll check. We'll check. Chalo, this one we have solved earlier already. I think you remember we spent a huge time behind springs. We told here in this case, if BC is burnt, then no change in tension in the spring. Okay. So if there is no change in the tension of the spring, it means what? That means this block M1 will continue to be in equilibrium. है ना? Correct. तो in that case क्या हो जाएगा? This M2 will move up. Right? कैसे? Because initially you think this is, let us say T1, this is T2, and this is M2G. Correct है ना? So that means what? That means T1 is equal to M2G plus T2. Correct. So we can clearly see that when is burnt, this is 0. So net force क्या बन जाएगी? T1 minus M1G. So it will start moving in the upward direction. So A is correct. If A is correct and if M1 is an equilibrium, so then C has to be correct because M1 का acceleration 0 है. So B and D automatically wrong. Right? No? Understood? Okay, चलो. प्रोफेसर सर?
सर M1 इक्विलिब्रियम में क्यों है?
क्योंकि मेरा मर्जी है. मैं ऐसे सोचा कि उसको इक्विलिब्रियम में रखूं तो रख दिया. तेरा मर्जी नहीं है तो उसको छुड़वा दे.
ओके.
मैंने क्या बोला कि if the string BC is burnt, there will be no change in tension in the spring.
ओके सर. ओके
तो
सर.
M1 तो पहले इक्विलिब्रियम में था. If there is no change in the spring tension, so अभी भी इक्विलिब्रियम में ही रहेगा.
ओके सर. थैंक यू सर.
Chalo, do this one. This is easy one. Okay, Sai. Very good. This is easy stuff. You do it. This angle is 90 degree only, no? Correct. So this is tension T. Here also tension T. Here it will be 2T. That's it. Okay, na? Banu?
Sir, is it ABC?
We'll check, Banu. Just give me 1 second. I'll check the answer and I'll tell you. Okay.
Okay, sir.
Slightly wrong, Banu. Check it once again. Pushkar.
Sir, ABD.
Yeah. Correct answer. Chalo everyone, let's go for it. It's a very simple thing. So just you take the force analysis. This will be 40 G sine 45 degree minus 2T is equal to 40 into A. This is equation number 1. And here you do T minus 20 G sine 45 degree is equal to 10 into A. This is equation number 2. So once you solve, we will get the value of you will get the value of T and A both by solving them. Yeah, Likhita, tell me.
Sir, got it. ABD.
Yeah, ABD is the correct answer. Fine. Okay. Chalo. Let's move on to the next page. Yeah, do it now. Yeah, Ratna, tell me. Pritam?
सर ये मल्टी करेक्ट है सर.
A single.
Sir, option A.
Okay.
सर मुझे ये लग रहा है.
Yogananda?
Option B.
Option B. Okay, we'll check. Snehita?
Sir, option A.
Option A. Okay. Yes, Vanu?
Sir, even I am getting A, sir.
You're getting A, Vanu?
Yes,
Read
sir.
the line, last line very carefully. See, it's very easy to understand because here also tension T, here also tension T, here is T, so here will be tension 2T. So we know minus T into V naught plus 2T into VA is equal to 0. So VA is equal to V naught by 2. So velocity of A with respect to ground is equal to V naught by 2 I cap. Velocity of B with respect to ground is equal to V naught I cap. They are asking velocity of A with respect to B. So VA with respect to B is equal to VA with respect to ground minus VB with respect to ground. So that is V naught by 2 I cap minus V naught I cap. It becomes minus V naught by 2 I cap. So that means I can write magnitude is V naught by 2, direction is minus I cap. Minus I cap means left. All right. So B is the answer. Okay, it was a bit tricky, not much. हाँ बोल.
सर थोड़ा ऊपर हो. हाँ सर, ठीक है. Thank you.
Chalo, do this one. In this question, you have to be a little bit careful. This is F1. No, sorry. I'm sorry. And this is F1. This side force we are taking it to be F1, and this side force we are taking it to be F2. Now solve. Ratna.
सर ऑप्शन सी।
ऑप्शन सी आ रहा है, चलो देखते हैं। See, in this type, what you have to solve basically, see, acceleration of the system. A system will be written as F1 minus F2 by small m plus capital M. Let's say this is equation number 1, right? And if you think that force equation for capital M, we can write F1 minus F spring is equal to mass into a system. This is equation number 2. And force equation for small m is F spring minus F2 is equal to small m into acceleration of the system. So these are the 3 equations which needs to be solved. If you solve this, you are going to get the answer. Remember, if the forces on the right hand side and left hand side are equal, then obviously it is not going to be producing any productive result, because the spring force will automatically be 0. Why? Because the system is not going to have any acceleration at all. Right? So that is one thing you have to keep in your mind, you know. All right, so keep it here. If F1 is equal to F2, F net external is equal to 0, acceleration of the system is going to be 0. Now spring force won't contribute to the acceleration of the system, because it will produce action reaction pair. Okay, please keep it in your mind. Okay, yes professor.
से किसी केस में ऐसा हो सकता है क्या स्मॉल एम और कैपिटल एम का एक्सेलरेशन अलग अलग हो?
हाँ, वो तो हो सकता है, क्यों नहीं? मतलब यू आर आस्किंग दैट स्मॉल एम एंड कैपिटल एम इज हैविंग डिफरेंट एक्सेलरेशन विद रिस्पेक्ट टू ग्राउंड?
यस सर।
नहीं, वो पॉसिबल नहीं है. That's not possible, because either the system will move rightward or leftward because of the net force acting on the system.
सर तो हम लोग इसको सिस्टम ले सकते हैं ना?
हाँ, हम
हाँ,
इसको
ओके
सिस्टम
सर।
ले रहे हैं ना. ये मेरा सिस्टम क्या है? मेरा सिस्टम स्मॉल m प्लस कैपिटल M है. अब इधर मेरा F1 लग रहा है, इन दिस डायरेक्शन वी आर गेटिंग F2. तो इधर F1 अगर ग्रेटर देन F2 हुआ तो सिस्टम राइटवर्ड मूव कर जाएगा. अगर F2 ग्रेटर देन F1 हुआ तो सिस्टम लेफ्टवर्ड मूव कर जाएगा.
ओके सर, थैंक यू
समझा
सर।
ना? राइट.
यस सर।
ओके, क्लैरिटी आया सबका? इज दिस ओके? फाइन नो? चलो एक और बहुत इजी क्वेश्चन कर लेते हैं. This is very easy, dead easy. I think you should do it in couple of minutes only. Please solve. Chalo. So this should be very easy. Why? Because you know that when the system is in equilibrium and more than two forces are passing through one point, so you know which theorem to apply. All of you know, right? It is Lami's theorem. Correct. So either we can solve it by Lami's theorem or we can do by force analysis, right? Like summation of fx equal to 0, summation of fy equal to 0. And this process, it will take much time actually. You know? So that thing we can do directly from Lami's theorem. So if I apply Lami's theorem, so let us have this 5 kg force weight in this direction. This is mg. So what is Lami's theorem? I will just make you remember that force divided by sine of opposite angle means f1 by sine alpha 1 is equal to f2 by sine alpha 2 is equal to f3 by sine of alpha 3. है ना? Professor?
Sir, T1 is equal to 25 Newton and T2 is equal to 25 root 3 Newton.
Okay, Professor, we'll just check. Just give me some time. I will check it. Okay, na?
Okay, sir.
So T2 by sine of opposite angle. What is the sine of opposite angle? This is T2. So this angle I have to take. This is 120 degree is equal to T1 divided by sine of opposite angle. This is the opposite angle. That is 150 degree is equal to mg by, this is mg in that direction. This is the opposite angle. So 60, 30, 90 is already done. 180 minus 90 is 90 degree. है ना? So from there you can get easily the answer. Yeah. If you want to get T1, you just write T1 by sine of 150 is equal to mg. Why? Because sine 90 is 1. So T1 is equal to mg sine of 150 degree and T2 is equal to mg sine of 120 degree. Okay. So as the answer is given is A and D. Correct option is A and D. All right. Chalo. That's all. Bye bye. See you tomorrow. Okay. Tomorrow we'll start the fresh session. Okay na? We'll proceed with your regular syllabus. हाँ पुष्कर.
सर कल भी आफ्टरनून क्लासेस नहीं है क्या?
अभी तक तो वही है. I think PPT ही चलेगा.
नहीं सर, आज तो क्लासेस ही नहीं है शायद से आफ्टरनून के.
ऐसा क्या?
हाँ सर, मैसेज आया था प्रिंसिपल.
अच्छा ठीक है, मैं कल क्लास में बता दूंगा क्या है क्या नहीं है. अपडेट क्लास में बता दूंगा. ओके ना?
ठीक है सर.
ओके. हार्दिक,
आफ्टरनून क्लास नहीं है सर.
बोल तो रहा है कि आज नहीं है. मैं मुझे उतना आइडिया नहीं है. ठीक है ना?
क्योंकि रोज पीपीटी चल रहा है इसलिए. हाँ, तो
ठीक है. चलो फिर. ओके. बाय 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 एवरीवन. बाय बाय.
Like a Hellcat. Hellcat. like a Hellcat.
what we have learned previously.